My group will be using the corn future as the data sheet, and the data on 25th November 2024 will be our population average, and the rest of the data will be our sample. So first of all, we'll be looking for the average or the mean of the data. So after summing up all the data and dividing by the total data, which is 20, we'll be getting the mean value as 432.75, and the mode will be 0. There is no mode for this data. Now we have arranged all the data in increasing order, and now we'll be looking for the median. After a while, we have concluded that the median is 433.5 plus 434.25 divided by 2, which equals to which is the value that will be calculated is 433.875. Now we'll be looking for the interquartile 1 value, which is 423.25 plus 424.25 divided by 2, that equals to 423.75. Since we have looked for the first quartile, now we'll be looking for the third quartile, which will be using the values of 440 plus 441.25 divided by 2, which equals the third quartile. The third quartile's value is 440.625. Now that we have the first quartile and the third quartile, we'll be looking at the max value, which is 447.2, and for the minimum value will be 416. Now that we have the 5-number summary, we can draw the box plot, and the box plot is as shown in the diagram on the screen.
Untuk soalan 2, kita perlu mencari 95% confident interval for close. So, dia punya formula adalah confident interval equal to mean plus minus Z darabkan dengan standard deviation perkan dengan bilangan punca kuasa N. So Z kita dah tahu 95% equal to 1.96. So kita perlu cari mean untuk close. So kita just plus all the data. Kemudian kita bahagikan dengan 20. So, kita dapatlah mean kita iaitu 433.45. Kemudian standard deviation kita dah tahu 10.15 dan bilangan bagi data kita adalah 20. Jadi, macam mana nak kira confident interval? Kita just masukkan dia ke dalam formula tadi. So, CI equal to 433.45 plus 1.96 darabkan dengan 10.15 bahagi dengan punca kuasa 220. So, kita dapat dah jawapan kita 437.898. Jadi, yang kedua kita hanya tukar simbol iaitu simbol plus kepada simbol minus. Jadi 433.45 tolakkan dengan 1.96 darabkan dengan 10.15 bahagi dengan punca kuasa 220. Jadi kita akan dapat jawapan kita adalah 429.00. Jadi untuk confident interval bagi soalan ini, kita akan dapat confident intervalnya equal to 429,437.898. Pula kita perlu mencari hypothesis testing at alpha equal to 0.05. So, data yang kita dah tahu ialah mean. Mean kita ialah 433.45, standard deviation dia adalah 10.15 dan bilangannya adalah 20. Mu kita pun dah tahu iaitu 424.75 dan alpha kita adalah 0.05. Jadi langkah pertama kita perlulah membuat hipotesis. H0 mu equal to kita punya mu iaitu 424.75. Kemudian H alternatif kita adalah mu not equal to 424.75. Kemudian langkah kedua kita perlu mencari nilai T. So kita lukis graf macam ni. Okey. Kita boleh tengok jadual. Nilai T pada alpha 0.05 adalah 2.093 dan sebelah kanan adalah positif, sebelah kiri adalah negatif. Jadi macam mana kita cari? Kita tengok dalam jadual. Pada nilai DF kita iaitu N tolak 1. N tolak 1 kita adalah 19 dan nilai pada graf kita adalah nilai graf two-tail. So, kita perlu tengok dalam jadual dan kita akan dapat nilai T kita adalah 2.093. Jadi, sebelah kanan adalah positif, sebelah kiri adalah negatif. Jadi, langkah 3 pula adalah kita perlu mencari T. Nilai T, jadi masukkan sahaja nilai 433.45 tolak 424.75 bahagikan dengan standard deviation 10.15 per punca kuasa 2, 20. Jadi T kita akan dapat 8.70 per 2.27. Jadi estimate answer kita adalah 3.83. Jadi kita boleh buat kesimpulan di sini bahawasanya T value kita 3.83 lebih besar daripada 2.093. Jadi H0 kita boleh reject. Jadi kesimpulan di sini kita dapat buat bahawasanya there is enough evidence to support the claim. The closing price has been changed at alpha equal to 0.05.
Okay, so now we are going to answer the question number 5. Sorry, my bad. Question number 4. Is there any difference between opening and closing prices of the data at alpha 0.1? Use the dependent sample technique. So, first thing first, we have to construct a table to compare between the opening and closing prices. So, we already construct the table. So, here is the table. So we have calculated D, which is our differences between closing and opening price, and D square is our value to help us calculate the standard deviation for this question. So first, the formula used is T equal to D bar minus mu D over standard deviation of D minus over divided by square root of n of D. First, we will answer the question about the difference. So we have the n equal to 20 D bar. We don't know D bar. So standard deviation we don't know, and mu is 0 because difference. So H now equal to 0, h alternative equal to not equal to 0. Oh, I forget alpha equal to 0.1. We have to draw a bell-shaped graph. So this is our alpha equal to 0.1 over 2, so we will get 0.05. So to find the t value, we have to look at the t table. So because of it is t table, we have to use the formula of number of sample minus 1. So we will get 20 minus 1 equal to 19. And from the table, we have to see the 19th value. So we will get 1.729. So we have to calculate the value of t now using the formula d bar minus mu standard deviation divided by square root of n. So how to find the d bar value? D bar equal to sum of d over n. We will get, so we will get the d value, the sum of d. We will get it from the table here. We get 14 over n. The total, we have, how many samples we have? We have 20. So n equal to 20. So we will use calculator and we will get, and the answer is 0.7. The value of d bar. So this, for the standard deviation, we have to use the formula. Formula is 1 over n minus 1 sum of d square minus sum of d squared over n. So substitute the value for each variable. We will get 1 over 20 minus 1 sum of d square. We will get it from the table that we have construct. D squared sum is 96 minus d 14 square over 20. So when we calculate, we will get standard deviation equal to 2.13. So next, we will have to substitute all the value to the formula. D bar equal to 0.7 minus mu equal to 0 over standard deviation equal to 1 equal to 2.13 divided by square root of n, which is 20. So we will get the value of t equal to 1.47. So therefore t is less than t 0.05 from the bell shape. That means you have to accept the hash now because it is outside. It is not in the rejection region. So hash null accepted. So the calculation is there is not enough evidence to support that there is any difference between opening and closing prices of the data at alpha 0.1. So that's all for the question number 4. So for the question number 5, is there any correlation between opening, high, low and closing prices? So first of all, we have to construct a table to make it easier for us to calculate the value of correlation coefficient. So we have to represent x, y, z and the value for x for opening, y for high prices and z for low prices and w for closing prices. So in this question we will use the formula r equal to n sum of x y minus sum of x times sum of y over n sum of x squared minus sum of x squared times n sum of y minus sum of y squared minus sum of y squared. And lastly, don't forget the square root. So for the correlation between x and y, which is opening and high, we will get 0.725. And for the correlation between x and z, which are x for opening and z, which is low prices. So use the same formula and we will get 0.970. So there are correlation between them. So next, the correlation between x and y, which are opening and closing prices. So use the same formula and substitute the values, and the answer we will get 0.908. And there are also correlation between them. And next, the correlation between y and z, which are low and high prices. So substitute all the values in this formula and we will get the answer is 0.980. And still there are correlation between them. And next, the correlation between y and w, which are for y is for low prices and w for closing prices. So use the formula that we have written up there and we will get the answer 0.961. And they are correlation correlation between them. And lastly, for Z and W, which are high prices and closing prices. So when we calculate by using the formula, we will get the answer 0. The R value is 0.969. So all the correlation have, so all of the prices, the closing, high, low, and opening prices, they are correlation between them. They are correlation between opening high, low, and closing prices.
For the last question, we will talk about the linear regression model. For linear regression model, we will use Excel. So first of all, you need to get the data from your lecturer by pressing at the button that I will show on the screen. For this part, it may be different to people because some Excel it can choose from the PDF, but for my Excel, I need to convert my PDF into the Excel workbook because my Excel only can take data from the Excel workbook. Next, after that, it will take you to the navigator. On the navigator, you will see 5 different tables. So for my case, I will take the table 4 because table 4 contains my data. Yep, the given data there. So this is the data after we press load. Next, go to the file, choose option, and after you choose option, you take a look at the add-ins and make sure that at your add-ins, the manage below is written as Excel add-ins. If it's already written as Excel add-ins, you need to press OK. So you are managed to do your multiple regression analysis. And after that, on the bar above, you can see the words data. So we click on the data again and go to the data analysis. On the data analysis, you will choose you use the bar, slide down and choose regression. After you find the regression, you click OK. Finally, we will start our multiple regression by using our closing data as the Y value, and for the X value, we will use opening, high and low. However, we need to take note that when you are taking the opening, high and low data, you didn't need to take one by one. However, you take 3 data all at once. Just use your mouse and take all the 3 data. And we need to make sure that for the date, we didn't take 25 November. Yeah, we only take 24 December until 26 November. I'm sorry, my bad. 26 November until 24 December. That's all. During the regression, you might notice the word output range. What is output range? Output range is the place where we want to put our output, the summary of the output. So don't forget at the regression to tick at the labels, and also at the output option, take the output range. And if you notice, there is the button light up, and that button, after you press that thing, you need to press in either of the tab where you feel comfortable to put your output. So after you press OK, the data will go to that place. Then after that, if you notice, you will have your summary output. However, it is really hard to see your summary output. So what you need to do, you need to press Alt, press hash, press O, press A, and press Alt again, press hash, press O, press I. So it will make your table is clearer to see. It will make your table clearer to see. Don't forget to only choose the tab where you want to adjust. Do not choose all of the tab. Just choose an I from I until Q for my case. If you put your summary output at J, you might need to choose from J until R. If you take from K, you might need to choose from K until S. So it is based on your tab. For my tab, I need to choose from I to Q, and then I press that buttons. It will show a better data for me to see. For this, if you are using Excel. However, you can use our mathematical equation, which is y equal to blah blah blah. They are already written on the screens. What is y? Y is the dependent variable, which means for when you are doing the mathematical equation, y will be our closing data. However, for the x1 or x2, it will be our independent variables, which is our high, our low, and our opening. So for the formula, I only show you x1 and x2, right? But for our case, we need to add another one, x1, x2, and x3. However, using the mathematical equation, we might make some careless mistake. So it is better for you to use Excel. That's all from us. Thank you.